Welcome all of you. We are in this chapter of sound now, 9th CBSE sound. Okay, so in this chapter we are going to learn about sound. Let's see. Let us quickly start with the chapter. Now, what is sound? Okay, if I simply ask you the question, what is sound? Sound is a form of energy. Just like we have light as a form of energy, we have heat as a form of energy. Electricity is also a form of energy. Now, sound is also a form of energy which we cannot see, we cannot, but we can experience. We can definitely experience sound. So sound is a form of energy. Now, how is sound a form of energy? Now, how is sound produced? Okay, how is sound produced? Sound is produced. Now, from our birth we have been listening to sound, but we never thought about this. How is sound produced? Okay, we are so used to this. Okay, sound is produced by vibrations. Now, it can be the vibration in my vocal cord. It can be the vibration in a bell that I am ringing. Okay, so I go and I ring the bell, and the gong of the bell makes the bell vibrate. The bell goes into vibration. Okay, and that vibration travels through the air, reaches our ear, and as it reaches our ear, it vibrates our eardrum also, and then the nerves in our ear, they take it to the brain interprets the meaning of the vibration. Okay, so then we understand something. Okay, so sound is basically produced by vibrations. Okay, vibrations. And so any vibrating body will produce sound. Okay, so it can, as I said, it can be an animal, it can be something that we are vibrating in order to produce sound. Now, I said that the vibrations reach the human ear and then we hear it. Not only human ear, it reaches any animal's ear and the animal hears it. Okay. Now, these vibrations, what are these vibrations like? See, when the vibration is produced, it pushes the air particles, and the air particles goes like this. Somewhere it becomes very densely packed, and then alternately it becomes rare, means less density of air. Again you speak, again you are ringing the bell, again densely packed air, rare. Densely packed air particles, rare. This is how the waves are proceeding. Okay, once dense air particles, one rare, once dense, once rare. Now these dense areas are called compressions. Okay, compressions. And the rare areas are called rarefactions. Okay, these are called rarefactions. So sound travels in air with the help of compressions and rarefactions. And thus it forms a wave. And what is this kind of a wave called? This kind of a wave is called longitudinal wave. Okay, this is a type of wave. There is another type of wave which is transverse wave also, but then we don't talk about, because when sound travels in air, it travels by this method, compressions and rarefactions. Next is, now sound can travel in air. Now don't think that sound cannot travel in liquids or gases. Sound can travel in air, sound can travel in liquids, that means sound can travel in gases, liquids, solids, all three. Okay, so sound can travel in all these three. Sound cannot travel without a medium. That is, sound cannot travel in vacuum. Okay, sound cannot travel in vacuum. It needs a material medium. It needs a material medium. Material medium means solids, liquids or gases, anything. Okay, all these three can make a material medium. Now, the particles are very close by in solids. So, sound is the fastest in solid, then less fast in liquids and the slowest in gases. Remember this. Okay, highest speed of sound is here, then next highest is here, and it is slowest there. Okay, so now if supposing a train is approaching, okay, and if you place your ear on the rails. Okay, if you place, sometimes children in the villages they do this, if you place your ear on the rails, you will be able to hear the upcoming train. Okay, so even before you can see the train. Okay, the reason is sound of the moving train is traveling through the rails faster and it is not traveling through the, so if you know the train is far away, you are placing your ear here, you get to hear the sound of the train coming before you can even see the train. The reason is sound of the upcoming train is traveling through the rails faster than through air, and so you hear it first. Okay, this is what is sound traveling faster through solids. Okay, so now this is an experiment to prove that sound cannot travel in vacuum. Here we have a bell, electric connection. This is an electric bell. This is a bell jar, glass jar, and this is a pump. Okay, which is pumping out air from this bell jar to slowly make it vacuum basically. So in the beginning we switch this on, this bell rings and we can hear the bell very well. Now what happens, we switch on the vacuum pump. Again we ring the bell, we do hear the bell, but the sound of the bell becomes less and less and less as this pump keeps on taking out air. A time comes when this bell is ringing, but we cannot hear it anymore because the full volume of this bell jar has become vacuum. And since sound cannot travel through vacuum, we cannot hear it anymore. Okay. So this proves that sound cannot travel through vacuum. Now let's quickly come to few characteristics of sound. Okay. Characteristics of sound is firstly the amplitude. Now, of that compression and rarefaction waves, I can make a graph like this. In this graph, the waves are going to go like this. Remember, this is not a transverse wave, but it is a graph of compressions and rarefactions. We have put the values and made a graph out. Here we have time and this is displacement. Okay, this distance, that is the maximum distance on either side of the mean position is called the amplitude. Okay, and amplitude of sound, and this depends on the energy of the source. Okay, if I am talking very loudly, if I have a lot of energy, I'll speak very loudly, amplitude of my sound will be high. Okay, SI unit of amplitude is meters. Okay, then energy is, it depends on high energy, more the energy, more the loudness. I shall give the definitions of these also. So more the energy, more the loudness. Amplitude is the maximum displacement on either side of the mean position of the wave. Okay, then comes frequency. Now here I have, supposing this is supposing 1 second is made here. Okay, and this is the, let's say this is the second. So at point A 1 second over, at point B 2 seconds over. Okay, so in 1 second this particular wave is making one, this is called crest, and this is called trough. Okay, one crest and one trough make one wave. So in 1 second, okay, here 0 to A, that is 1 second, this wave is making one full wave. So number of waves made per second number of full waves made is called frequency. In this case it is equal to 1, and hertz is coming from the word hertz. Okay, and hertz is the SI unit of frequency. Number of waves happening in 1 second is the frequency. Okay, let's come to velocity. Velocity is nothing but the distance traveled by the waves. Okay, distance traveled by the wave in per unit time. Okay, so if here the distance traveled in 1 unit time, if in 1 second the wave is moving from 0 to A, then 0 to A, value of 0 to A is going to be the velocity, distance traveled per unit time is the velocity. Okay, so that is again velocity is measured in meters per second. Wavelength, the length of this wave. Okay, so length of one wave, that is in this case it is 0 to a only. Okay, length of one full wave, that means it has to take one crest and one trough in consideration, that is wavelength. Okay, so wavelength is written like this, lambda. Okay, wavelength, this is the sign for wavelength. SI unit is meter, and length of one full wave is a, you can write it like this. Okay, and length of one full wave is the wavelength of the wave. Now, talking about the characteristics of sound, if there is one more thing, which is time period. Okay, I missed it. It is written with T. Time period, SI unit is seconds. Okay, and it is the time taken by one wave to the wave to complete one complete vibration. Okay, so here to complete one complete vibration, I had seen it was 1 second, right? Okay, now I can have, supposing this is, if supposing it is completing this is 2 and 3, let me draw it like this. Okay, so 1 vibration over 2 vibration 3, all this has been made in 1 second, just giving an example. Okay, then the frequency is equal to 3 hertz, right? Because 3 vibrations made in 1 second. Okay, then time period is how much? To complete one vibration, how much is the time? Time period is 1 by 3 seconds. Okay, so time period, because if I had taken 1 second, it wouldn't be very clear. So I took this. So I took this 3. So frequency and time period have this relation. F is equal to 1 by T. Okay, F is 1 by T. That is the relationship between frequency of a wave and the time period of the wave. So if a wave takes 2 seconds to be formed, okay, one wave is taking 2 seconds to be formed, that means time period is 2 and frequency becomes a half, because in 1 second only half a wave is formed. Okay, now distance is equal to speed into time, right? You know this, we have used it in maths. Now here, if time period I take as t, that means the time taken for one full wave, speed is s, okay, and distance is, if time is t, then the distance will be lambda, that means the wavelength of one wave, because this distance it is making in one time period. Okay, so if I take it as, now by t is equal to s, you can also take as v, velocity, then 1 by t that you see, that is taken as, this is sine of frequency into lambda. So this is a very important formula. V is equal to n lambda. Okay, V is equal to n, this is for frequency, this is for wavelength. So velocity is frequency into wavelength. Okay, you have to remember this and you have to remember this. These two things you will have to remember for all your numericals. Now frequency, as I said, amplitude depends on, loudness depends on amplitude. Frequency gives us pitch, means pitch depends on frequency. What is pitch? Okay, every person's voice has a different pitch. Ladies' voice of ladies is supposed to have a higher pitch, means thinner voice. Men's voice will have a lower pitch, means thicker voice. Okay, so pitch is frequency. Okay, so frequency gives us pitch. So higher the frequency, more the pitch. Less the frequency, less the pitch. Okay, talking about frequency is a inherent property of the source. Means what? In sound, you'll see in the lab they'll use a tuning fork and things like this. Okay, so this every tuning fork, the frequency of the tuning fork will be written on it, because as it is produced, the frequency depends on its shape, its material, its weight, its mass, all that, it depends on that. Okay, so if it is on this handle, the frequency of this particular tuning fork will be written. Similarly, each of our vocal cords have a different frequency. Okay, so frequency is something which does not depend on the medium, whether a wave is going in solid, liquid, gas, some other type of nitrogen, oxygen, okay, whatever gas it is going on, or it is going in whichever liquid, frequency of the wave, if the source is same, will remain the same. Very, very important thing. Okay, if the source changes, only then the frequency changes. So V is equal to n lambda, this is same. Okay, so velocity will be different in, for the same source, velocity will be different in air, gas, it will be different in solids, liquids. Okay, so then what happens, if frequency is same, wavelength keeps changing medium to medium. Okay, and that is why velocity changes. Okay, so we'll stop here and we'll continue sound in the next video, okay, where we are going to do many more very interesting things. So as of now, this is it for today in this video. Please subscribe the video if you have not subscribed till now. Many more video on sound. Part 2 is going to come. This is part 1. Part 2 is also going to come. Okay, and also lots of numericals are going to come in sound. Okay then, bye all of you.